everybody, this is Mrs. Ewald signing in, and welcome to Molality and mole fraction. So just to recap really quickly what Miss Heaton went through in her last podcast about about MolaRity. MolaRity is equal to how many moles of your solute per volume of solution, so liters of solution. And the unit for that is a capital M. Today what I'm going to go through is molality, which is different. So it's a small difference as far as the name, molarity, molality, just a letter simply. However, it's a huge difference when you talk about the unit. So molality, we use a little m, and I kind of make it a little cursive so you don't confuse it with meter. But it is just a lowercase m. And what it is the concentration of a solution in moles of solute. So what it is moles of solute, which is very similar to what we've already looked at. However, what changes is the denominator, and it's now per kilogram of solvent. So this is only looking at the mass of the solvent, not the mass of your solute. Here, you're looking at the whole volume of your solution. And so that would include whatever you have as far as your solute added to it. So molarity is one thing, molality is another. Don't confuse the two. And why do we use molality? Typically, not all the time, but typically we talk about molality when water is not the solvent, and so you have some other solvent, an alcohol, something like that. And also when studying properties of solutions related to vapor pressure. And so this is going to be a huge component next week when we start talking about colligative properties. So that's why that would be important. So this here is kind of like learning your ABCs before you move on to learn words. So you need to know molality before you could do anything more with it. So this here again just simply summarizes between the two, molarity versus molality. Make sure you understand the unit, and always remember this is per mass of solvent and this is volume of solution. So you could always figure out the difference between the two. So moving on to some examples then with it. So let's right away apply. You should all be there and ready to do that. So we want to know the molality of a solution when it has 255 grams of acetone. And so we give you the formula for that. This here is going to be your solute because it's dissolved in 200 grams of ethanol. So ethanol is your solvent. Now, it also provides to you the density of the ethanol. Now, why would you need that? Well, you actually don't need it in order to do molality because the solvent only needs to be in kilogram. But you are going to need the density of something if it's not water in order to go from grams to liter. So this would be more appropriate if we had to figure out molarity. So please keep that in mind. You should remember how to use the density to go from gram to liter or liter to gram by simply just taking the mass then and then going from gram to, let's say, mil first because that's what's provided. And so this would be 1 and 0.9. Then go from mil to liter, and you're done. Okay? So again, side note, commercial, you're going to use density. If you need to go from gram to liter, that would specifically be for molarity. What's nice about this is that for molality, all we simply need to do is just change that from gram to kilogram. So I'm going to write out my formula. Molality is equal to moles of my solute over kilogram of my solvent. I've already identified the two. What I need to do is convert 255 grams of acetone into moles. So off to the side here, I'm going to write 255 grams of acetone. So it's CH3 to CO. I'm going to go from gram to mole. You're going to use your handy-dandy periodic table, calculate that to be 58 grams. And then solve to get to mole. And so that you plug in over here. So punch it into your calculator. And I'm just going to write out the full amount, 4.39 96551724. That's what I see on my calculator. I'm just going to hold off to round until the very end. I'm now going to take that divided by my mass. So I'm going to take 200 grams and convert that to kilogram. So you're just simply moving the decimal 3 places to the left. So that would be 0.2 kilogram. And that's mole divided out. And you would get approximately, how many sig figs do you use? Because there is a decimal here, so that's 3 sig figs, that's 3. You're going to have 3 in your answer. So 22.0 molality of CH3 2CO. And by the way, we shorten molarity to molar, and so you could say instead of molality, molal. Okay? So, if we wanted to know how many grams of silver nitrate are needed to prepare a 0.125 molal solution in 250 mils of water, what would we do? So we are given, I would identify your given, molality, and a volume. So we need to convert that volume into kilogram, and so that would be 250 mils of water. Go from mil to gram. Now we know the density of water is 1, so 1 gram per mil. And then go from gram to kilogram. 1 gram is 1,000, I'm sorry, back the truck up. Kilogram is larger. So 1 kilogram is 1,000 grams. So you're going to divide by 1,000 and end up with 0.25 kilogram. So I have 0.125 molo is equal to mole of solute, in this case it's silver nitrate, all over 0.25 kilogram. Again, that's what I solved over here. And now I'm just going to multiply, end up with my mole, and so I will get 0.03125 moles of silver nitrate. But the question is how many grams of silver nitrate, so always be careful to look at what you're solving for. And so this would be, the molar mass is 170 approximately grams per silver nitrate for 1 mole. Multiply, and then you would end up with, you would have 3 sig figs. Oops, sorry about that. You would have 3 sig figs, so it would be 5.31 grams of silver nitrate. Alright, so that would be just another problem using molality. The last thing I want to go over is mole fraction. And we're going to be using more mole fraction later when we do another calculation. So this is just simply a ratio of moles of solute per total number of moles. Or it could be also mole of solvent per total number of moles. So it's a very simple calculation. Let me go ahead and show you what I mean. So you would either have mole of solute, so mole fraction of solute. We show mole fraction by showing an X. So this would be mole fraction of solute is equal to mole of solute over mole of solute plus mole of solvent. Okay, and if I wanted to know mole fraction of the solvent, it would be mole of solvent over total mole. Mole of solute plus mole of solvent. So the hardest part really is just, it's time consuming because you always just need to convert everything to mole first, then plug it into this equation, and then solve for your mole fraction. You're going to notice because you're just dealing with moles, you're taking mole divided by mole, you're just going to end up with no units. So mole fractions have no units, and so you could always just simply answer it with the value or say x of whatever is equal to, and then circle. So to give you an example, you would have to go from 100 grams of sodium chloride, so that is your solute dissolved in water, so that's your solvent. You have to take both of them first, and convert to mole, and then plug it into one of your equations. And so here we want to know the mole fraction of the solute. And so we're going to take mole then of the sodium chloride over moles of sodium chloride, so the same value again, plus moles of water. And so you're going to need to first do your conversions. So take 100 grams of sodium chloride and 100 grams of water, and first convert that to mole. And so this would be 1. You'd have the molar mass here. 1 molar mass here is 18, and so on. Get your moles, and then plug it into the equation. I am actually going to let you do that on your own. So that way, when you come to class, you will have an answer for number 1, and then also go ahead and complete the answer for number 2 by plugging it into molality and to figure out what your molality of the solution is per how many kilograms of water. So go ahead and calculate this, find out the molar mass, figure out your moles, plug it into the equation. Once you have that, you should then be able to calculate molality. Sound good? So this is Mrs. Ewald signing out, saying happy molality-ing, I guess, and mole fractioning. All right. Peace out.